Hello everyone, welcome back to Infinity Physics. In this lecture, we are again going to discuss law of conservation of momentum. See, in the first video, I have explained it in the detail. In the second video, which was related to space, right? One scientist is there which is showing you how in space the law of conservation of momentum can be proved. So I hope you have watched that video so you can understand these things clearly. Now in this lecture, I will teach you how to get that equation, how to prove the law of conservation of momentum in a very different way. So first, what is the statement? The total momentum of an isolated system means the system which is closed or isolated from all sides. No energy can come inside the system and no energy can leave the system. So remains constant. See, conserved. What is the meaning of the conservation? Conservation means there is no change in the total amount. There is no change in the total amount of the energy, no change in the total amount of the mass, and no change in the total amount of the momentum. So here conservation of momentum means the total momentum of the system remains constant if the system is isolated. Let me explain you with the help of some example. Here, suppose you have two objects. Let us say you have two balls, one with a mass of 4 kg and another is a mass of 2 kg. So initially the ball with mass 4 kg is moving with velocity, let us say 3 meter per second. And this 2 kg ball is at rest, means its initial velocity is 0. Now this system suppose is isolated. Now what is the total momentum of the system? It is momentum is equals to mass into velocity. So 4 into 3 is 12 kg meter per second plus 2 into 0. So the total momentum of the system is 0. Now suppose these two balls collide, and after collision these two balls starts moving all together. This is 2 kg and this is 4 kg. Both the ball starts moving all together. Now what is the total mass of the ball? What is the total mass of the ball? It is 4 plus 2, 6 kg, right? And what is the initial momentum of the system? 12 kg meter per second. So this whole system, these two balls now will start moving with the velocity of 2 meter per second. Now what is the total momentum of the system? The total mass is 6 kg and both the ball move with the velocity of 2 meter per second. So here 6 into 2, which is 12. So here the initial momentum of the system is 12 kg meter per second and the final momentum of the system is also 12 kg meter per second. So what is happening? The momentum of the system remains conserved. Conserved means no change. The net change in the momentum is 0. 12 minus 12 is 0. So change is 0, not momentum is 0. Right? So this is the meaning of the law of conservation of momentum. So here final momentum is equals to initial momentum, or we can say the change in the momentum is 0, means no change, that is momentum is conserved. Now let us derive the equation. Let two balls A and B, here ball A and ball B, here this is the A and this is the B, and moving with velocities u1 and u2. This ball and ball A of mass m1 moves with velocity u1 and ball 2 of mass m2, that is ball B of mass m2, moves with velocity u2. The total initial momentum of this system, what is the total initial momentum? So m1 u1, mass into velocity of the ball A plus mass into initial velocity of ball 2. So m1 u1 plus m2 u2. So the total initial momentum of this system before collision is Pi is equals to m1 u1 plus m2 u2. Now they are colliding. See, This is moving with velocity u1, this is moving with velocity u2. Now they are going to collide. Now during collision, they exert some force on each other for some time t, and then after collision they starts moving with the new velocity v1 and v2. Here also you can see the velocity changes. So sometimes it may possible the velocity change. If the mass of the both the balls are similar, then the velocity will not change. If one of the ball is heavier and other is lighter, then the velocity will change. So after collision, the ball A of mass m1 moves with velocity v1 and ball B of mass m2 starts moving with velocity v2. So here during collision, A, that is ball A, exerts force F1 on B, and ball B exerts force F2 because they are colliding like this. So this will exert force in this direction and ball A exert force in this direction. So ball B exert force F2 on A in this direction, right? According to Newton's third law, that is action and reaction are equal and opposite. So when they collide, they will exert equal and opposite force. The direction are opposite. This exert force on this direction and this exert force in this direction. So these forces are equal in magnitude and opposite in direction. So we can write F1 is equals to minus F2. Minus sign indicates the direction of this force is opposite. Now after collision, A and B moves with velocities v1 and v2 respectively. Now the total final momentum of the system becomes, after collision, the total momentum m1 v1 plus m2 v2. So this is the total final momentum of the system after collision, and this momentum is the total initial momentum of the system before collision. We have to prove that these two momentums are same and the change in momentum is 0. So let us try to prove that. Now according to Newton's third law, during collision F1 is equals to minus F2, but F is equals to ma. So this is the Newton's second law. So you can write from second law. You can write Newton's second law. So F1 is equals to m1a1 and F2 is equals to m2a2. So I can put these two values here. So here F1, instead of F1 I can write m1a1 is equals to minus m2a2, but A is equals to V minus U by T. Therefore A1 is equals to V1 minus U1 by T. See, the time of collision is same. Right? Both ball collide with each other in the same time. So time of collision is same. So I can write only T. And A2 is equals to V2 minus U2 by T, only T. Right. Now again if we put these values of A1 here and A2 here, then we can easily obtain the equation. So on putting the values, so I am putting this A1 here. So M1, what is A1? V1 minus U1 by T is equals to minus M2 into what is A2? V2 minus U2 by T. Now this T and this T get cancelled. So we are remain with M1. I am multiplying this inside. So it is M1 V1 minus M1 U1 is equals to minus M2 V2. We are multiplying. Now this minus sign will get inside. So it becomes plus M2 U2. Now take all the negative signs. If here you find negative sign, then take it towards the right side, so it becomes positive. And here you have negative sign, take it towards left side, so it becomes positive. This is the easiest way to remember. So just on solving, so m1 v1, now I'm taking this towards this side, so plus m2 v2 is equals to here m2 u2, and if I take this towards right side, then it is m1 u1 plus m2 u2. Now here m1 v1 plus m2 v2, m1 v1 plus m2 v2, which is the final momentum of the system, and m1 u1 plus m2 u2, this is the initial momentum of the system. Hence we have proved that the momentum of the system before and after collision remains constant, and the change, that is pf minus pi is equals to 0. The change in the momentum is 0, that is momentum is conserved. Hope you have liked my lecture. Please share and give your feedback in the comment section. Have a nice day.